All right. Well, thank you guys very much. Thank you so much for inviting me to come and talk, and thank you all for coming to listen. Can you hear me in the back? All right. So I've had a lot of conversations already today about what people want to do with their lives, and this is a thing I've thought about a lot. I'm still thinking about it. I'm still trying to decide what I want to be when I grow up. So what I thought I could do today is not just talk about what it is that I do currently, but how I got to be here, which is a long and winding and strange road, and certainly not where I set out to be. It's certainly something I feel very strongly about, is that being a scientist does not restrict you to one and only one future. And so the things that I've thought about doing with a background in science have been certainly out of the box of what I was trained to believe I could do as a scientist. And I'm still looking for new and interesting things to do next. So I'm very passionate about that topic. If you want to talk to me about it later, please come up and talk to me. So on that note, I will say that I first decided what I wanted to do with my life when I was approximately 4 years old. This was my career aspiration, right? And it's, why ever not, right? She had an invisible jet and a lasso of truth. You probably are all too young to have ever seen the Linda Carter television show, but Wonder Woman was amazing, and I grew up watching this, and so that was who I was going to be for a couple of years. And my parents, to their credit, did not dispel this idea that this could be my career trajectory, but school did. But then I was about the ripe old age of 8, and I did my first scientific experiment. And my father gets a lot of credit for the design of this experiment. But hold on, I'm going to move this away from hitting it. Basically, what I did was I planted radishes, and I put them in the north, the south, the east, and the west. And I watched them grow, and I tracked their height, and I put one in the basement in the dark under a lamp. And so what I did was, over probably 6 weeks or something like that, I watched them grow, and I measured their height, and I graphed it on graph paper because Excel doesn't exist yet in this world. And this was like the greatest experiment, and I was so excited, and I loved it, and I loved having data and all this stuff. And so really, really early on, I was already on this path. I was going to be a scientist. And then what happened next reinforced this idea, which was a few years later. I was in 8th grade, I believe. Our science teacher assigned us to read the newspaper for a week and find an article about science and write a report about it. And the Chicago Tribune happened to be running a 4-part series about what they were calling at the time, which I've never heard anybody in the field actually say, was genetic engineering. And it was this new thing, and this was the 80s, mind you, and it was new and exciting, and it was this frontier. And there was an article about this, the Flavor Saver tomato. This was the first genetically modified food ever to be sold on the market commercially. And it was still a few years out when this article was written, but I just thought this was incredible. And there was something in that newspaper article that really struck me on all of these different levels, both intellectually but also emotionally. So somewhere in there must have been some stuff about, and I've never been able to find a reprint of this article, there was something about sort of all the other things you could do with this technology, right? You could make tomatoes, what this were tomatoes that were going to have a gene in them to slow down their ripening, right? So you could pick them and then ship them across the country, and they wouldn't be rotten mush, they would now be ripe tomatoes. But you could do all these other things with this technology. You could engineer rice to grow in the Sahara without water, and you could make bananas with edible vaccines for kids in Southeast Asia or something, so I was fired up on all these levels about the science, but also about the humanitarian aspect to it. And so for me, from a really, really early age, I guess I was about 12 or 13 when I read this, the idea that science and saving the world didn't go, they went hand in hand. That was the message that I got. And it would be years before I would encounter a lot of people, actually, who would say, huh? Right? Who didn't believe that those things went together. But for me, from the very beginning, science and saving the world always went together. And so what I went on to do about 10 years after I read this article was I actually went and tried to save the world with science. So I'm all fired up. It's a terrible photo. I went to West Africa, the Ivory Coast, over there on the corner. And this is a picture of me and my friend Jeanette in the lab. And so this is me and Jeanette in the greenhouse. Jeanette was amazing. We were probably about the same age, but we could not have had a more different upbringing. So I grew up in suburban Chicago. I had just come out of an undergrad degree in biochemistry. I worked in labs in high school. I worked in labs in college. Jeanette grew up in a farming village in the center of the Ivory Coast in West Africa. And as is really, really common in the Ivory Coast and lots of other parts of the world, she had never finished high school. So you have to take these exams. They're very hard to get to the next level. She didn't pass. She dropped out. She had a kid. She was a single mom. She never finished high school, but she knew how to farm. And so she got a job at this research station. And she got a job in the field, and she was very bright. She could read. She'd gotten pretty far. She was very smart and capable in math and reading, and she was doing a lot of translation for other people in the field, and so they kept promoting her. And so ultimately they promoted her to the lab. And this was a brand new lab, and so when I got there, they'd been running for about maybe 6 or 9 months, and it was going to be the new molecular biology lab. And there were 4 of us in there. We had the only PCR machine in the country that worked, and we were trying to study the rice plants that we were working on at this research station at the genetic level. And so this was really an incredibly revelatory experience for me, because I got there with my fancy background in education, my Fulbright fellowship, and Jeanette was teaching me molecular biology, right? Because, of course, I'd never worked in an environment like this. I'd never worked on rice. There were all these things that she was figuring out how to do given the circumstances we were working in. And so without access to something like liquid nitrogen, how do you isolate DNA from rice plants? Well, Jeanette figured it out, right? Take the leaves, put them in an oven for a certain, she figured out how many days and what temperature, and then she's figured out, put them in a coffee grinder, now you can pulverize them, now we can isolate DNA. She was terrific. And she was teaching me. But half of her job, I would say roughly, was spent washing and sonicating and drying Eppendorf tubes and pipette tips. So if you guys have ever worked in a lab, you know exactly what I'm talking about. They come box of 500, you put you put a piece of dry ice in them, you close them, you throw them at your neighbor, you throw it away, right? Not in Côte d'Ivoire. We were trying to use these things for 3 months at a time, right? So this whole idea of like sterile PCR that you've been trained in, yeah, out the window, right? These things are covered in whatever that you've been using them for months. But Jeanette's job, this was her time. She was smart, she was troubleshooting experiments, but half her day was spent washing pipette tips. And this was an incredible eye-opener for me. Because ultimately what happened to this lab is they ended up developing 17 varieties of rice that were specifically bred, not GMO, but specifically bred for things like the kinds of pests that occur and that eat rice and ruin crops in West Africa. And so somebody like Jeanette, who never finished high school, who's spending her time washing and drying Eppendorf tubes, has contributed to a discovery that is feeding millions of people. And that's only one lab with one PCR machine. Imagine what tens of thousands of labs like that with tens of thousands, millions of Jeanettes could accomplish. And so with this image in my head and this lesson in my head, I did the thing I was supposed to do, which was go to graduate school. Here, by the way, is a lab. This is a typical lab. This isn't in Kenya. It's not in Côte d'Ivoire. But while I was in Côte d'Ivoire, I went to the university, and it more or less looked like this, right? So if you picture, and I've been in a couple of your labs today, right? If you think about the equipment in your labs, and you take a look at this, right? And what you can see is it's kind of empty, right? And so this was the kind of university environment that a person like Jeanette, if she'd even had the chance to go to school, would have gotten to go to school in. And so this had a really profound impact on me. When I came back to the US, I'm skipping slides. I will skip. Here I am, back in the US, in grad school, the way I was supposed to be all along, right? This was what I was supposed to be doing. And I came back and I started working in this lab where, of course, now I was freaking out on a daily basis, right? Don't throw away that Eppendorf tube. How can you do that, right? You walk through the halls at night, and I don't know if this happens here, but a place like Harvard, you walk through the halls at night and people have put a water bath out in the hall, and by the next day it's gone. Custodians have taken it away. it's gone. It's just disappeared and nobody knows. You ask people, where does this stuff go? And nobody knows. The basement, I guess. Right? Nobody has any idea. And here's the reality, so I'll go back a slide. This is the average budget of somebody like Jeanette, or that lab that I showed you in Africa. Somewhere between $0 and maybe $20,000 a year. The average American scientist, lab head, spends $82,000 or upwards just on equipment every year. So that leaves you with labs that either look like Jeanette's or look like mine, right? Where you either are washing and drying Eppendorf tubes, or you're putting microscopes in the hall for the custodians to throw away. That's the dividing line, and this had a profound impact on me. And I'm obviously the kind of person who saves and recycles everything already, and so this, to me, seemed like an unbelievably wasted opportunity. And so what happened was that I made friends with a couple of other graduate students who had had similar experiences. One of them had just come back from teaching a course in El Salvador. One had worked in a lab in Ethiopia and in China. And we banded together over our collective outrage about this problem. And our collective desire to do something. And because we were scientists, had we been public policy students, we might have written a lot of op-eds. But because we were people who liked to get something concrete done, we wanted to do something for these folks that we had met and worked with around the world. And so what we did was we went in search of what happens to that equipment when it disappeared out of the halls by the custodians. And we found it. We found it in basements, and we found it in labs that were moving, and we started to collect it. They gave us a little room in the basement of the university, and we started to collect this stuff, and we went looking for people to give it to, basically. And fundamentally, that is how I came to be doing what it is that I'm doing today. Because when we went looking for people who needed lab equipment, of course, we found tons of them. And so this started to grow. It was not always the most OSHA effective, safe environment to be working in, but we started to grow, and this was filling a need that was obviously acute around the world. And so, and to sort of tell you, I was telling some students at lunch today, I did not set out to start a company. I did not set out to do, this was a compulsion, we just did it. And so if there's anything else that I truly, really believe in as a career path planning tool, it's to pay attention to the things that you are doing that nobody can stop you from doing. Because heaven knows I did not have copious amounts of spare time. This was my Saturdays, this was at night, this was mostly Saturdays and Sundays, right? I was trying to do a PhD. I had a lot of long nights in front of a microscope in the dark, dissecting fruit fly salivary glands. But I was doing this anyway. And when I talked to my friends about it, the difference in my emotional excitement about this, about putting old equipment from the basement in boxes and shipping it to Ecuador, was so much more apparent than when I talked about my thesis research. And so there came a point in time when somebody hit me over the head with it. And I tell this story again. So a friend of mine said, hey, this business plan contest is opening up a track for social enterprises. You should join, you should enter. And I looked at him in all dead serious and said, with what? It never occurred to me that this thing that I was spending all my time and emotional energy doing could possibly be my career. Because I was supposed to be a professor, right? Wasn't that what I was supposed to do? I was supposed to get a PhD, and then I was supposed to do a postdoc, and then I would obviously become a professor in a tenure track. That's what you do when you're a science major. And so this idea that entrepreneurship, nobody had said the word to me before. Social entrepreneurship was an even more foreign concept. And so I am proof positive. I stand here before you today to prove that you can actually learn a lot of other things that you were not originally setting out to learn. And you can take your scientific background and go with it in directions that nobody previously instructed you to go. And that at the end of the day, fundamentally, it is not rocket science. You can learn it. And if there's anything else that you believe after talking to me today, it is that you will be able to teach yourself whatever it is you need to learn to do whatever it is you want to do. Because if you're passionate enough about it, you're going to figure it out, right? When you have to learn something for an exam, you make sure you get it, right? You figure it out. And that is true of anything. because I had never seen or read a business plan before I entered a business plan contest. And we won. And so you can learn this stuff. It is not rocket science. You can learn it. It's just math and vocabulary. And so, after quite a lot of twists and turns, we entered this business plan contest and we won. We didn't win the money, which was tragic. We got honorable mention, I suppose. But so I didn't quit graduate school, which was the good thing. I finished my PhD and I went on and then applied for more funding. And so today, Seeding Labs is going to be 5 years old in January. And so this is what we are here to do, which is to take those early experiences of what is holding back scientists around the world and try to discover solutions and implement them. I really believe, I don't like to talk and write about stuff, I like to do it. And so what we are really trying to do is ensure that anyone, wherever they're born in the world, has access to the tools to do great science. And what are those tools? Usually, those tools are a couple of these things. Equipment, fundamental, right? You have a great experimental idea. If you have nothing to do it on, it's theoretical, right? But there's lots of other things. And the more I do this, the more I'm uncovering about, it's really complicated to do science. It's not easy, and there are a lot of factors involved. And I think because of my own background, the way that I think about doing this is very experimental, right? It's to figure out what the problems are, to try something, to try it again better next time. You know, I don't believe in saying we're going to do 150 labs around the world in year one, because we don't know what works in one. So I'm trying really hard to be very scientific about this, and at the same time to really try to understand all of the problems. I might not be able to solve all of them in my lifetime, but if I can figure out what they are, maybe somebody else can. And so these are, it's a kind of a depressingly long list of things, but these are some of the problems that really are holding back science all over the place. Right? Mentorship is enormous. Having the technical expertise, you might have the equipment, but if you don't know how to set it up, what do you do, right? This is one of the things I feel most strongly about, which is networks and exposure, right? People live in isolation. The scientific community back in the day, and I love to think about this, right? 400 or 500 years ago, the science community was like 10 guys, right? The Royal Society of London, everybody knew everybody else. And so you could be in Germany or England or Ben Franklin in America, you were all writing letters to each other about your discoveries. And there was only one journal to publish them in, Proceedings of the Royal Society of London. And so the science community knew everyone in it. And then we became globalized and fractured, and now people don't know. And I frequently get questions like, oh, there's universities in country X. You know, and so part of what I feel really strongly about doing is connecting all of these people, because let's face it, you guys are on Facebook 24/7, but you know what? So are the students in Nairobi, and so are the students in Buenos Aires. So why aren't you collaborating with each other? You don't care where your friends are anymore because you know how to reach them electronically. So why does it matter where your colleagues are? And so I think fundamentally Seeding Labs is about connecting all of these dots and having the science community help itself to get stronger. So how do we do this? Well, we go back to the basement, first of all, because this is still the biggest problem that everybody is it's very emotionally sensitive, this issue of having enough equipment to work on. When you don't have the tools at your disposal, you often feel powerless, right? I have a great idea, I can't do it. So now, you know, we're getting kind of more formalized and better as this goes along. Like I said, we're not even 5 years into this, really. So we start by trying to identify great universities and great people around the world. We worked really hard to try and develop, and we're still working on it, an application process. Because unfortunately, we're tiny, we're a small organization. We don't have the resources to help everybody everywhere yet. So who do we pick? We want to make good bets, make good investments. And this January, we got 65 applications from 26 different countries, which gives you kind of a sense of how many people out there really want to do science. Good question. And so we're trying to develop methods to identify who's going to be the next great place and the next great people. And find not just great scientists, but great universities where they work. And we're focused pretty much on public universities right now. Because what happens if you are not in the US is basically the government pays the top students in the country every year who graduate from high school to go to university, right? And so those are kind of the brain trust of the country, is the University of Nairobi, the University of Ghana. So my philosophy is I want to build up those places. The institutions already exist. I'm not going to start a university from scratch by myself. The institutions exist, the government's invested in them to some extent. Let's try to make them as great as they can be. And at the same time, what we're doing is trying to reach out to the science community here where we live and try to solve two problems at once, right? So I have spent time in a lot of basements in the last several years. And I've been in basements not just of universities, but things like pharmaceutical companies. And we have a problem in this country. We buy things and then we replace them, and we don't know what to do with the old things. And so we're trying to solve two problems at the same time. The problem of what do we do with the stuff we don't want here that's still good, and what we can do to help people who don't have access to affordable lab equipment at the same time. And so if you're developing a drug, you want the newest and coolest, top of the line, state of the art, whatever it is, which you should have, right? If you're developing the next medicine for heart disease, I want you to have that. That's great. But what do you do with the model that's 4 years old? You stick it in the basement, goes in a landfill, gets sold for scrap metal. Nothing really useful has ever been done with this stuff before. So we've had to build up a whole infrastructure to get this stuff out of the basements, separate the junk from the stuff that's good, and make sure that then we can match it up properly with people who are going to use it. So we spend a lot of time back and forth. You said you needed electrophoresis, how's this? You said you wanted that, but that model doesn't exist anymore, so what about this? And we custom build shipments of lab equipment. Here is a volunteer from a pharma company in Boston who's helping us sort glassware. And this is the kind of scale that we're doing now. So the very first shipment when we were in the basement at the university was 5 boxes that I carried up by myself. And now we're doing things like whole 20-foot shipping containers full of lab equipment. So we're shipping these things on boats across the ocean, 20 feet long by 10 feet high, full of equipment for like a whole department or a whole university, right? And so these are going into labs where they're not just doing research, but they're also teaching classes, like all of the lab classes that you guys take. Because those folks are going to be the next generation of doctors, next generation of high school science teachers, elementary school science teachers, pharmacists, nurses, physicians, researchers. Everybody is getting trained at these universities. So we want to make sure that they actually get a chance to do an experiment hands-on, because there's nothing like that, right? You can learn about it in a book, but until you do it yourself hands-on, it's theoretical. So we've sent a lot of equipment to a lot of places so far since I've been doing this. We have sent equipment to 16 countries around the world. They are working on an incredible array of things. Working on tuberculosis, on HIV, on diabetes, on wheat and corn, and one guy has actually discovered that Viagra helps you get over jet lag, which was an interesting and unexpected discovery. And I feel very proud to have contributed to that. So we've sent a lot of equipment to a lot of people around the world, and we're about to send it to even more countries and more places. And that's not the end of the story, right? You can have all the equipment. If you don't have a good idea, what do you do? If you don't know how to use it, what do you do? And so, as part of this tactic of experimentation, we've started to build other projects on top of this. We want to make sure it's not sufficient to me that the equipment got to the door of the university, right? I don't consider my job done to have moved a microscope from point A to point B. I wish that was my whole job, because that's hard in and of itself. And this is the challenge of entrepreneurship in a social setting, right? If I just wanted to move units, I would run Apple, I would run Nike. But I have to make a social difference. And so I have to think about the people who are using it and how to make sure that they can best use it and to help them do that. So we've started to build other programs on top of that. So one of the things that we have is a fellowship program, where we've brought scientists from the universities we've equipped here to the US to work in labs for a summer, for 2-3 months at a time. And this is great because, one, they get to use the equipment we've just sent them here in a lab where all the other issues about power and water and bugs and whatever else doesn't exist. So you get this kind of isolated bubble to learn how to use stuff in for a little period of time. They also get to meet scientists here, and this goes back to that idea that I talked about connecting people around the world, right? So it's been phenomenal because you don't usually think of scientists as great diplomats, right? Scientists, yeah, okay, they're not the most social animals in the universe, but scientists are really good at talking to other scientists. And so what's been phenomenal to see is what happens, like, I saw a chemist who grew up in Manchester, England, now he works in Boston, Massachusetts, sat down at lunch with a guy from Nairobi, Kenya, and within 10 minutes max, they had, their lunch was sort of pushed to the sides, they had napkins out, and they were scribbling chemical structures on the napkins. Because that was the language that they shared, right? And those guys, that was 3 years ago, and those two guys, Lewis and Evans, are still in touch. And they're still doing projects together. So Evans from Nairobi, he came and he spent 10 weeks in Lewis's lab in Boston. He went back. Lewis went to Nairobi this winter and helped him set up a computer lab, a computational chemistry lab. He's going to go back again. They wrote a grant together to the American Chemical Society that they just got last month. So they're going to do more projects. They started developing a curriculum together. To me, this is the point, right? I'm the science matchmaker. I want to bring people together and see what happens. It's not up to me to make them do science together. It's up to them. But that spark has to happen somehow, somewhere. And so I'm really interested in not only having that spark happen, but creating the environment around those people so that it can go somewhere, right? So that Lewis doesn't meet Evans and say, well, it'd be lovely to collaborate with you, but you obviously have no equipment, right? So to set up the environment so that these things can go somewhere. So these are some of the Seeding Labs fellows. They come here, they work in phenomenal labs, they learn all kinds of new ideas. We do things with them like how to write really good grants, because it's fundamental at the end of the day, if you can't get money to buy chemicals on the equipment that I gave you, you're not going to be able to do an experiment anyway. So we work really hard on some of that stuff. Things like how to give a great presentation of your science, how to write a paper. These are all things that it's not always easy to learn them. You can't necessarily learn them out of a book. So we're trying to substitute for that learning experience in a really short period of time. And like I said, we're sending folks in the other direction. And this is what I hope is someday in 10 years, the science equivalent to the Peace Corps, right? Where American scientists get to go abroad and work in these labs that we're helping to equip. Because I think it really does broaden everyone's horizons. And it was really fascinating. This woman here, Amanda, was giving a lecture to a group of students at this university in Kenya. And she said, well, science is just hard. She just sort of threw that off the cuff because we know, right? Science is hard. And this stunned the Kenyan students. They're like, what do you mean science is hard for you? You have everything. And she said, yeah, but science is hard. Science is still hard, right? And so it's providing the opportunity for people to break that barrier down and realize how much you have in common, including the struggle to do science, and the kinds of things, the kinds of problems that everybody finds interesting around the world. So, like I said, one of the burdens of social entrepreneurship is to know whether what you're doing is working. And this is really hard because the collecting data is tough, right? So basically what we know, so we've equipped labs that training 4,000, probably about 5,000 students as of today, all over the world. 16 countries. This is a group of pharmacy undergraduate students in Nairobi. There's an acute need for people who are trained pharmacists in Kenya. There was previously only one school that trained them. Now there's two. So these guys got all of this chemistry equipment for their basic chem labs. But you want to use science. You want to use this equipment to do something with it, right? And so this is Sebastian. He's down in southern Chile. This is the first ever turf microscope in Chile. He put it together himself from parts that he found in our warehouse. Because, oh yeah, I know how to use that, I know how to use that. The scientists that we've helped have increased the amount of funding that they're getting to do their research. They're training a lot more people. They're publishing a lot of papers. This patent is also from that guy who discovered that Viagra helps you get over jet lag. He's doing a lot of really interesting research on circadian rhythms and sort of sleep cycles and things like that. And then there's a wonderful scientist named Ricardo. So he was a postdoc here in the U.S. from Argentina originally, and he got hired to come back home and start up his lab. And the people at the university in Rosario, Argentina said, oh, fantastic, you're going to bring stuff from the US, right? Because here's your lab, it's an empty room. So what do you do? So we helped to equip his lab back in 2004, and what he did was he actually has been working on multi-drug resistant tuberculosis, and that's a really terrible problem, right? Because if you're resistant to multiple drugs to treat TB, what do? But what's really amazing about multi-drug resistant TB is that it's actually even really hard to detect, and so the diagnostic they were using took 45 days, apparently. When he told me this, I was absolutely blown away, right? A month and a half to find out whether you have MDR TB. How many people have you infected by that point? So Ricardo, in his lab in Argentina, has taken that and actually cut it down to 4 days. So he's optimized this technique, this diagnostic, so that you can now test for multi-drug resistant TB in 4 days. And the Argentinian Public Health Service was testing this in the field last time I talked to him. So one lab can really make an incredible impact if it has access to the right stuff. So I thought I would end by telling you another story of one of my newest favorite scientists that we worked with this year. Her name is Mildred, and I think she's an absolute rock star. So Mildred believes that she knows how to solve the problem of malnutrition in East Africa. And the thing that it's an unbelievable problem. So globally, the World Health Organization puts out different numbers all the time. They're never 100% sure. But it's possible that 750,000 people annually have a chronic food shortage, right? And this is either actual, not access to food at all, or lack of access to properly nutritious balance of food. In Africa alone, it's right 250,000 people, including some estimates say 40% of the women in Africa, and an enormous number of children. So this is a huge problem, right? And Mildred has been working on this. It's not only is a problem in terms of health, but it's an economic problem. This is very interesting, right? So people are hungry, they can't work. Kids are hungry, they can't go to school, or they go to school and they don't perform as well, right? And they're chronically ill. And so all of this together, right, the cost of treating all of these sick children, the cost lost of productive workers in your economy, costs a lot of money to be hungry, as it turns out. And so Mildred has come along, and she's been working on this for a while. And she's been working with kids in villages that are outlying the capital of Nairobi in Kenya. And one of the things she realized was they actually have access to pretty good range of nutritious food, but only part of the year, right? And so part of the year, things like this are available. This is an African indigenous eggplant, right? And so part of the year, you have eggplants to eat and all of the antioxidants and vitamins that come along with them, and part of the year it's not around. And so you don't have it, right? And so you have these cycles of hunger and plenty over the course of the year, which really wreaks havoc on your body. And they talk about this a lot in Kenya in particular. They call it the hungry season. And so Mildred, took a look at this issue, and she's a chemist. She's an analytical chemist. So what can an analytical chemist do to solve malnutrition? Well, what she wants to do is take these kinds of plants and isolate from them the nutritious compounds, the things that are actually going to make a difference on people's micronutrient levels, and turn them into supplements that you could eat the year round. And so in order to do this, what does she need, right? She needs access to a population of people. Well, she's got that. She needs a lab to work in. This is her lab. This is the lab at her university when I first went there in 2009. And whether you're an organic chemist or not, I think you can see that this is not the most state-of-the-art lab, right? We've got a shaker and at least one column and maybe some beakers, but they're broken. This is a fume hood that has not been a fume hood for many, many, many years. It's now basically a shelf, right? There's a freezer, so that's a good start. So this was Mildred's lab when I first met her. And the thing that Mildred most needs to be able to do this research is this. This is called an HPLC, high performance liquid chromatography. And the low end models, the low price of $12,000. High end models cost upwards of $30,000. right? I mean, this is a fantastically efficient thing. So if Mildred had, in order to do what she's trying to do with this, it'll take her a week to isolate one sample. If she has this, it'll take her hours to isolate dozens, right? So what would you rather that Mildred have access to? So this was Mildred when I met her the first time 3 years ago. And we've been working with their university ever since to equip their labs. And so that picture of guys unloading that big device from the side of the container, that was equipment going to her lab in 2010 when we started working to build that up. And I was really thrilled that finally this is in February. This is Mildred's HPLC. That's Mildred over here. That's the dean. And there's me in the background. Right, and I don't know if you guys have ever been at the loading dock. When a lab equipment gets delivered to your university, there's not usually a parade, right? It just quietly gets unpacked. So I neglected to put a picture in here, but you can look it up online, on YouTube actually, because it was on the nightly news in Kenya when this lab equipment was delivered to their university. And 3 busloads of students dressed in lab coats drove to meet the container truck and went in a convoy up the main highway outside of Nairobi, and purposefully drove at about 5 miles an hour so that they would stop traffic, because that was their goal, was to make this big splash, right? Lab equipment's coming to the university, let's stop traffic. You know, and outside the gates of the university, the president of the university was there with the university flag on a pole. It's like NASCAR. She waved them into the university gates. The dance troupe was there and performed. The school band came and performed. It was on the nightly news. It was a really big deal that lab equipment was coming. And so the dean of the university came just to open this box to see the HPLC that Mildred is going to use. And so Mildred and some of her colleagues came to the US this summer. They spent 10 weeks in Boston. She not only knows now how to use this great high-tech HPLC, but she knows how to set it up and calibrate it. And since she's been back, she's already teaching workshops to the folks in her department on how to do this. So she's now the reference person for this entire campus on how to use this. And that's phenomenal, right? Because a year ago they didn't even have it. Now they've got somebody who's the world expert in using it. And she also got to go around, we took her around to a lot of universities locally so she could meet other folks. So this woman is actually originally from Kenya herself, Rose. She's a postdoc now. She's been in Boston for about 10, 12 years. And she's an unbelievable expert at calibrating all of these things. She's phenomenal. And she also works on micronutrients. Imagine that. And so now, Mildred and Rose have the same research interests. They've got the same setup of equipment, more or less. Rose actually has about a room full of 10 of what Mildred has one of. Right? And now they're talking about writing grants together and collaborating and what they can do together, because Mildred has great access to people and plants and things that are local to Kenya. And Rose has great access and knowledge to things like this. This is a really state-of-the-art NMR machine. There's one NMR machine in the entire country of Kenya. They've kept it running for 12 years. I don't quite know how. It's absolutely amazing. This is I think an 800 megahertz NMR. The one they have in Nairobi is at 200 megahertz. I don't know if you've ever looked this excited standing in front of an NMR machine, but this made her day. Right, and now she and Rose can do these things. She can send samples to Rose because they know each other, they know their shared interests, the conversation's gotten started. And so that's really what we're trying to do with Seeding Labs, is build more stories like Mildred and Rose, or Lewis and Evans, because I think, to me, this is where the future of science is going to go. So I always include this slide to keep myself humble. These are the things I hope to do in the next however many years of my life and career. We've got a lot of ideas, as you can see. We could not do it without a lot of really cool partners. So we work with sort of universities, we work with scientific societies, with a lot of companies, and we work with students. And so this is what I was going to end on, which is basically that we are actively looking for people to start Seeding Labs volunteer chapters. We have a few in the Boston area. We've got one in New York. We'd love to have one in Richmond. So if you are interested, this is the website to go to send us your information, to read about it, and to get in touch with us, because you guys are the next generation of leaders in this field. And we have lots of folks who are just like you all over the country and all over the world, 17 countries and counting, who would like to meet you. And so we'd love to have you guys get involved and make this be a movement of scientists for scientists. And so I will leave you with Diego, who I've talked about a lot today, Viagra for jet lag, but he really said it best, which is this idea of finding solidarity in science, right? We don't think of ourselves often as having a role outside of our particular lab. My job is to pipette things, clear liquids between clear tubes. That's my job. That's how I'm going to contribute to the world, and it absolutely is. But the moral of the story is there are so many ways you can contribute to the world while still being a scientist or with the things you learn as a scientist. And there's an incredible world of colleagues and people out there waiting to meet you. So I will be happy to answer questions.